Hey everyone, in this video we're looking at GCSE chemistry and we're doing some exam revision, specifically looking at the common 6 markers. And this topic we're going to focus on in this video is atomic structure, history and energetics. So the first 6 marker we can get is development of the model of the atom, which is AO1. And here we have to describe how the alpha particle scattering experiment led to the plum pudding model being replaced by the nuclear model of the atom. So this is an example of the experiment that we're going to talk about in the answer. So, the original idea, the plum pudding model suggested the atom was a sphere of positive charge with negative electrons embedded throughout it. The experiment we mentioned is alpha particles with positive charges were fired at a thin sheet of gold foil. The results and conclusions. Most alpha particles pass straight through. This proved that the atom is mostly empty space, refuting the solid plum pudding model. Then some alpha particles were deflected at large angles. This showed that there must be a concentrated positive charge at the center of the atom that repelled the positive alpha particles. Then a tiny fraction bounced straight back. This proved that the center of the atom contains a dense mass concentrated in a tiny volume, which we now call the nucleus. Next question says evolution of the periodic table, which is AO1. Question says, Mendeleev's periodic table was accepted by the scientific community, whereas previous versions like Newland's were rejected. Explain how Mendeleev organized his table and why his version was successful. So, we can say the organization. Mendeleev arranged known elements in order of increasing atomic weight, which is mass, but crucially, he switched elements if their chemical properties didn't match the group profile. He left gaps in his table for elements that he realized had not yet been discovered. Predictions. He used properties of surrounding elements to accurately predict the physical and chemical properties of these undiscovered elements. For example, gallium, aka aluminium. Acceptance. When these elements were later discovered and perfectly matched his predictions, scientists accepted his table as correct. Early tables failed because they strictly followed atomic mass, forcing elements into groups with totally different properties. Next question is required practical 4, which is temperature changes, looking at AO1, AO2, and AO3. Question says, describe an experimental method to investigate the temperature change when varying volumes of sodium hydroxide solution are added to a fixed volume of hydrochloric acid. Explain how to minimize errors. So the setup, we place a fixed volume, for example 25 centimeters cubed, of hydrochloric acid into a polystyrene cup. Place the cup securely inside a glass beaker for stability. Method. Measure the initial temperature of the acid with a thermometer. Add a small volume, which is 5 centimeters cubed, of sodium hydroxide solution using a measuring cylinder. Put a lid on the cup, stir the mixture gently with the thermometer, and record the maximum temperature reached. Repeat the experiment, adding cumulative steps of 5 centimeters cubed of sodium hydroxide each time, going up to example 40 centimeters cubed, washing the equipment between trials. Minimizing errors such as insulation. So here you use a polystyrene cup and a lid to act as thermal insulation, minimizing heat loss to the surroundings so that the temperature reading is accurate. Next question is reaction profiles and bond energy, looking at AO1 and AO2. The example question is explain why a chemical reaction can be exothermic or endothermic. Refer to the energy required to break bonds and the energy released when the bonds are made in your answer. So we've got a graph here of exothermic reactions and the potential energy, as well as for endothermic reactions. The rule: bond breaking is endothermic as it requires energy input, bond making is exothermic as it releases energy. So exothermic reactions. The energy released when making new bonds in the products is greater than the energy required to break the existing bonds in the reactants. Overall, energy is transferred to the surroundings, causing the temperature of the surroundings to increase. Endothermic reactions. The energy required to break the bonds in the reactants is greater than the energy released when making new bonds in the products. Overall, energy is absorbed from the surroundings, causing the temperature of the surroundings to decrease. Activation energy. This is the minimum amount of energy required by colliding particles to start a chemical reaction, represented by the peak on a reaction profile diagram.